In the last section, we learned about properties of regular parallelograms. Now, we're going to learn more properties about special parallelograms. Now, all the properties that we learned in section 5.5 apply to all these special parallelograms because they are parallelograms. Okay? So, we're going to go through the conjectures. We're going to go through a little ideas here. And we're going to start with a rhombus. Okay? So, in your notebooks, sketch yourself a rhombus. Remember, a rhombus is an equilateral parallelogram. Okay? So, it's equilateral here. Now, what I want you to do is I want you to draw the diagonals of the rhombus. Okay? Now, remember, in a parallelogram, the diagonals bisect each other. Okay? So, we have the diagonals bisecting each other of the rhombus. Look at this green triangle here and the blue triangle here. We can see that these two triangles are congruent. Therefore, all these little angles in here are going to be congruent. Because of CPCTC. Okay, the triangles are congruent by side, side, side. Therefore, all corresponding parts of those congruent triangles are congruent. So now, these two angles are congruent, and they're right next to each other, and they form a linear pair. If a linear pair are congruent, then they must be 90 degrees, because that's the only way you could get 180 by adding the same number together, 90 plus 90. So each of these here is going to be 90 degrees. Well, if two lines intersect to form 90-degree angles, well then they must be perpendicular. So, the diagonals of a rhombus are perpendicular and they bisect each other, which we already knew. Okay, and this was C49 on page 292. Okay, so now we learned a new conjecture that whenever we have a rhombus, the diagonals are going to be perpendicular bisectors of each other. Okay, so now let's also look what they do to the angles. Okay, we already saw that the green and blue triangle are congruent, so the corresponding parts of congruent triangles are congruent. So this angle is congruent to this angle. Well, this triangle is also congruent to this triangle, so this is congruent to this and over here. Well, if we have two angles being split, if we have an angle being split into two angles and they're congruent, does that mean it's an angle bisector? And so for over here too. Okay, so now not only do the diagonals are perpendicular bisectors of each other, we also know that the diagonals of a rhombus bisect the angles of a rhombus. Okay, and that was C50, also on page 292. I'll give you a second to copy those down. Okay, so in review, the diagonals of a rhombus are perpendicular bisectors of each other, and also the diagonals of a rhombus bisect the angles of the rhombus. Okay. Moving on, we're going to look at investigation 3, which is about rectangles. So what I want you to do in your notebooks, sketch a little rectangle. Okay, it doesn't have to be perfect. All right, and remember what a rectangle is. It's an equiangular parallelogram. So all these angles are going to be congruent here. Okay, we know it's a parallelogram. All right, now let's draw the diagonals. All right. We already know that the perpendicular. We already know that in the parallelogram, the diagonals bisect each other. Right? They already bisect each other. We already know that. Now let's take a closer look, okay? Take for instance, this blue triangle here. Okay? And then we're going to take this green triangle here. Okay, both of those triangles contain the diagonals. So let's redraw them on the side. We have this here, and then we have this here. Okay. So we already have an angle congruent. What else do we have congruent? Well, we know that this side is congruent to this side because opposite sides of a parallelogram are congruent. And we know that this side is congruent to this side for the same reason. So what do we have? We have two congruent triangles by side, angle, side. Okay? If we have two triangles that are congruent by side, angle, side, then all corresponding parts of congruent triangles are congruent. And this is congruent to this. So now we know that the diagonals of a rectangle are bisectors of each other and they're congruent. So let's copy down that conjecture. C51, this is on page 293. The diagonals of a rectangle are congruent and they bisect each other, which we already knew because it's a parallelogram. Okay, so copy down that conjecture, C51, page 293. And now we have one more special parallelogram to go over, and that is all our favorite, the square. Okay, and we know that a square is defined as an equilateral rectangle or an equiangular rhombus. So if it's both a rhombus and a rectangle at the same time, it shares the same properties as a rectangle and as a rhombus. So let's fill in this conjecture C52 on page 294. Okay? The diagonals, because we were talking about diagonals for the rhombus and the rectangle, of a square are congruent from the rectangle, they're perpendicular from the rhombus, and bisect each other because it's a parallelogram. Okay? So, there you have it. All right? So, in review, let's take a look. Okay? First, when we started talking about quadrilaterals. Okay? Then we split off. We talked about kites. Then we split off. Talked about trapezoids. Then we got more specific, and we talked about parallelograms. Okay? So, all these three are different, but they do share one thing, that they all have four sides. Okay? Then we got more specific about parallelograms. We talked about a rhombus. And then we talked about a rectangle. Okay? And they shared the same thing as a parallelogram, all the properties, but then they had their own specific traits. Okay? Rhombus being an equilateral, and also about its diagonals, and then a rectangle had its own special properties that we just learned in the conjectures. And then we came back full circle to what's known as a square. And it shares all the properties of a rectangle and a rhombus. Okay? So, write this little diagram down. After you're done, work on page 294, numbers 1 through 13. Okay, and then take out your ditto, 5.6, and work on that. Again, if you have any questions, you are more than welcome to come after school, room 303. I will be more than glad to help you with anything, okay?